So we have our batch predictions and we're ready to continue, right? Well, unfortunately the output is not very human readable. For instance, what is item ID 800 on the third line? Who is user ID 2, which isn't even listed, but we know it's the third line, which corresponds to user index 2. What's the problem here? We enumerated the users and items, but what we really need are the visitor ID and content ID, which we can tie back to our original data. We map from visitor ID and content ID, but we need a reverse mapping to get back from our enumerations. What we really need are visitor ID and content ID in our prediction files, not the enumerated user ID and item ID. Of course, we can do this reverse mapping in post-processing, but can we do it while writing the file instead? Even though we typically will do training on a periodic basis, on a nightly or hourly snapshot based on some time window, the datasets can be too large to be able to take advantage of using in-memory tools like pandas. So we need a way to do this and be able to handle the scale. We should use TensorFlow Transform to first create the group by dataset, then create the mapping vocabulary of visitor ID to user ID. Then we can use that vocabulary to reverse map when doing predictions. Let's see how that would look in a data flow graph. TensorFlow Transform uses Cloud Data Flow in the analysis stage to create assets that TensorFlow uses in training and prediction. Here is this example's data flow graph. Let's walk through each step. First, since we were using Google Analytics data from BigQuery, we will read that in. Next, we'll use TensorFlow Transform for the analysis to get the proper statistics like building the vocabularies. Then we'll create the transform function that TensorFlow will use to do the correct mapping. This will create the vocabularies of visitor ID to user ID and content ID to item ID that we can use for the map and reverse map. Now that we have the vocabularies, we can create the group by datasets for both users and items. Just as before when we were using pandas, Dataflow will convert our group by datasets into TensorFlow records. Finally, we will write our pre-processed files to cloud storage so they can be used by our TensorFlow model. The training code remains the same. Instead of pandas pre-processing our data, the Dataflow job writes out TF records containing item ID and user ID. Our batch prediction code takes that, looks it up in the vocabulary, and writes out our files that contain content ID and visitor ID. We just need to make a few additions to the batch prediction code, and everything will work perfectly. First, we'll define a new function, createLookup. It uses the transform function assets to read in the vocabularies. We'll call our createLookup function for both item and user vocabularies to use for our reverse mapping. Lastly, we'll look up the vocabulary when writing out the user ID and item ID. This is easy and doesn't require a dictionary because we're dealing with indices here and can just return that element based on index location of our vocabulary list. Let's test your knowledge. We want a scalable way to generate predictions that directly tie back to the original data and not just enumerated indices. We should use TensorFlow Transform to first create blank, then create blank, and lastly create blank. Choose the answer that best fills in the blanks. The correct answer is C. To use the Wallace matrix factorization estimator, we need to convert from our human-readable user and item identifiers to enumerated indices. However, without a reverse mapping, the predictions will not be in the correct form for us to easily understand them. Therefore, we want a scalable way to generate predictions that directly tie back to the original data and not just enumerated indices. We should use TensorFlow Transform to first create the group by datasets so that each item has a list of each user that interacted with it with their corresponding ratings, and each user has a list of each item that they interacted with also with the corresponding ratings. Then, we create the vocabularies to perform the forward mapping from the group by datasets to enumerated indices, which can then be used in the Wallace matrix factorization estimator. Lastly, we create the predictions using the TensorFlow Transform assets to create a lookup to do the reverse mapping from our predicted enumerated indices to our original data formatting.